2 source transformations, and a Thevenin Equivalent Circuit. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. However you solve for VA and VB, that's up to you. I don't want to go through a long rigmarole about solving these, but you have to separate. Obviously, you have to separate one of these. Here you have VB minus VA and VB, and then you have to separate one of these in terms of VA and VB. And then substitute one into the other and do some algebraic manipulation. Now I'll tell you, you can spend an hour on this. I have Mathcad and I don't expect you to have it, but here's how I solved it. I just stuck this in Mathcad and I said given, and there's special functions that you can do to make this work. That VA minus V2 over R123 and all this equal to 0. And then write the second equation, and then there's a solve function, find VA and VB, and here are the functions we get. So if I could figure out how to copy that down for you, I would. But we get VA. I'll write this much down. Alright. VA is equal to V2 R4 times R6 plus R5 divided by, it's a long equation here, all in parentheses, R4 R6 plus R6 R123 plus R4 R5 plus C R123 R5 plus R123 R4 plus R123 R5. Alright, and then well, that was long. VB is equal to this. V2 R6 times R4 plus C R5 divided by, this is a long, these are both long, R4 R6 plus R6 R123 plus R4 R5 plus C R123 R4 plus R123 R5. Okay, so those are solutions for VA and VB. Clean that up a little bit. And let's get back to where we were. Alright, so those are solutions for VA and VB. Now, solving for VA and VB with these values, we get the number, no, let's just go around, roll down. Now, alright, now again, I used Mathcad to solve this just so it would, just so it'd be a little bit easier for me to fool around, because there's plenty of room for mistakes. You can use a calculator to figure this all out. But as you can see, I put this formula, I just copied it in Mathcad. If you have Mathcad, then great, use it. If you don't, you're going to have to roll through this the hard way. So as you can see, I plugged in all my values here in Mathcad, first source transformation, and then R1 plus R2, R123, and then here I got VA equal to 9.26 and VB equal to 30.75. I'm going to plug those in, or just write those down actually. I have VA equal to 9.26, that's going to be in volts, and then VB equal to 30.575. That's also in volts. Okay, so the current that we have is I beta is equal to which is the driver for that current source, is going to be equal to VA divided by R4, and that comes out to 0.031 or 31 milliamps. So let's go back up here and take a look at what our voltages come out to. As you can see, this voltage does come out correct. V at VA is 9.25, V at VB is 30.575. These are the values we calculate. And in the circuit, when you run this operating point, a DC operating point, these are the values you get. You also get these in. Now, in order to Thevenize, now that's our Thevenin voltages. VB is 30.575, and our current, what we're going to have to do is find the current for, if you want to do a Thevenin equivalent circuit, you have to do what's called short circuit current at the output.
Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.